Everybody so far so good, right? It's just a revision from intro one. I'm not making any, no earth-shattering discoveries. Okay, now we have a car.
What? No way.
Sitting on a table. What's the one force I guaranteed know it's going to have?
Gravity.
And since it's sitting on a table, what's the table doing to it? Pushing it up. What do we call that force? And we call it the normal force. Now, what will be the equation written as? Newton's force equation. Sigma Fy.
Equals n minus.
Everybody knows how to do coordinate systems, right?
Yeah.
Okay, so the reason why I'm writing it this way is because I've chosen my coordinate system as X and Y. Just a normal coordinate system. So is this car moving?
No.
Okay, so that means this is going to go to, and I can get n equals mg. What if this car is accelerating?
Which way? Yeah.
Okay, let's say accelerating towards the right.
Well,
How does that equation change?
It doesn't change the y direction.
Good.
In the y direction.
It starts moving towards the right with an acceleration of 1.5 meters per second squared. What happens to this equation?
Nothing.
Absolutely nothing. But what will happen if it starts doing that, and let's say we even put in friction. So this starts to accelerate that way with acceleration A, and there is friction also in this situation. What direction will friction act?
Yeah.
So it should act. And how many kinds of frictions are there? What are they called?
Static.
Kinetic. That's it. And anyone remember the formula for friction? Mu n. Right? So what will happen to the x direction? I have to treat it separately. So that means it is accelerating in that direction, but friction is acting in that direction. So the only force that I have is friction. Nothing else is acting on it. Where will my sigma F arise in this problem? So, well, that's me writing the force equations. So then this means this will become MA, and this will still remain 0. So our equations will reduce down to MA equals minus F of S, and 0 equals N minus mg. So far, so good? Okay, now I'm going to add another thing to it. What if there is a push force on this that's acting on this direction? How do my equations change? And this is in the presence of push force. So I will still write sigma fx and sigma fy. The push force is in the positive direction, minus force of friction. And I still have my normal going upwards by mg. Okay, that means, and this object is accelerating. So what will happen to my sigma fx and sigma fy? So plus p minus friction, 0 equals n minus mg. Okay, now let's do a little bit of a change. What if I still have a push force, but at an angle? So instead of the push force being in this direction, what if my push force is now directed that way? What do I have to do? Anyone remember? Components, woohoo! And what will that look like? Sigma fx, sigma fy. Do you notice how I always start sigma fx and sigma fy? Okay, now what are all the forces? So I have to now use my components. So if this angle is, pick an angle, this angle is theta. I should actually redraw that. So this is my push force. This angle is theta. That's my car. So what is this? If this is P, this will be P sine theta. And that's my base angle. That will be P cosine theta. So then what will be my sigma fx? P sine theta. And the directions will be this way and that way. Minus friction still exists. And then for my y direction, it will be N, which is always going to be there, minus mg, and then downwards P cosine theta. So if there is acceleration, what will happen to this equation? That will become ma. So what will I be left with? Ma equals P sine theta minus f, and N equals mg plus P cosine theta.
Wouldn't you be like adding to your friction force by pushing down on it too?
No, because the sines and cosines will account for that.
Oh,
So everything, yeah, so your friction will change, but it accounts for it. It'll be a different number that comes out,
but it's still there.
but the equation itself will not change. This is the really cool part of about writing equations this way, because now you're not worried about the directions as well, and everything takes into account. So now if this car started to move in a circle, what will be the only change in this equation? Everything remains the same, except this part of the equation, if it moves in a circle, becomes mv squared over r. Everything else remains the same. Nothing changes. So if we stopped accelerating, what will be the change? So let's say if this car stopped accelerating, that part goes to 0. That's the beauty of doing it this way. Everything else fixes itself.